Hi, I'm Miss Hall, and this is Lesson 73, Reference Angles and Using Reference Angles to Evaluate Trigonometric Functions. Reference angle relationships. Let theta be an angle in standard position. The reference angle for theta is the acute angle theta prime formed by the terminal side of theta and the x-axis. So there are 4 quadrants the terminal angle can be in. We'll start with the terminal angle in quadrant 1. So this is my angle theta. And since the terminal side is in quadrant 1, theta prime is the exact same as theta. That is the only quadrant that works for. Quadrant 2, if your terminal side is in quadrant 2, then your reference angle is right here. It is the terminal side and the x-axis. It is that angle. There it is. If your terminal side is in quadrant 3, then the reference angle is the angle formed by the x-axis and the terminal side. And if it's in quadrant 4, then again, the reference angle is formed by the terminal side and the x-axis. Example 3, finding reference angles. Find the reference angle theta prime for theta equals 5 pi over 3. I prefer to translate these all into degrees. So I multiply by 180 over pi because I'm more used to working in degrees. Get rid of pi. This is really 60. So I have 300 degrees. And now, let's see, this is 0 degrees, 90, 180, 270. So it's beyond 270. 300 is 30 degrees beyond 270. So I'm going to make myself a little note here that it's 30 degrees. And I know that quadrant 4, right, this is a right angle between the x-axis and the y-axis. So this theta prime plus 30 has to equal 90. Therefore, theta prime is 60. So my reference angle is 60 degrees, but because it was given to me, theta was given to me in radians, I should convert this to radians. So I'll multiply 60 degrees times pi over 180 degrees. Make the degrees go away. Divide both by 60, I get 3. So pi over 3. Theta prime is pi over 3. That is the reference angle. Okay, now B, we're going to find the reference angle when theta is negative 130, 0, 90, 180, 270. Okay, I know that this is 90, so negative 130 is going to go here. That's 90, and then 40 more degrees. This is 40 degrees, right? Because this is 90 plus 40 is 130. And this quadrant is a 90-degree angle. So theta prime, I can tell by looking at it, is 50 degrees. Theta prime is 50 degrees because 50 plus 40 is 90 degrees. And I can give my answer in degrees because that is the way theta was presented. Reference angles allow you to evaluate a trigonometric function for any angle theta. The sign of the trigonometric function value depends on the quadrant in which theta lies. We're going to use these steps to evaluate a trigonometric function for any angle theta. 1. Find the reference angle theta prime. 2. Evaluate the trigonometric function for theta prime. 3. Determine the sign of the trigonometric function value from the quadrant in which theta lies. Okay, so what this chart is telling us, right, we have our 4 quadrants. 1, 2, 3, 4. And if you put that together with a couple of pieces of information you know, which is that in the unit circle, each point is cosine theta, comma, sine theta, and that in quadrant 1, both coordinates are positive. In quadrant 2, the cosine is negative, sine is positive. In quadrant 3, any point in quadrant 3 would have an x value negative and a y value negative. In quadrant 4, the x would be positive, the y would be negative. Okay, so those are the cosine and sine values. And you can see how, let's see, cosine in quadrant 1 is positive. Sine in quadrant 1 is positive. And tangent is also positive. Tangent is positive because you need to remember the relationship that the tangent of theta is equal to the sine of theta over the cosine of theta. To get a tan, you need more sun than clouds, is my memory technique. So a positive divided by a positive is also a positive. Okay, so we could go through, and you can see how my diagram matches the provided one. What some people teach is all students take calculus. And what that means is that for A, all trigonometric functions are positive. S, sine is positive. T, tangent is positive. And C, cosine is positive. Now, all students take calculus only looks at the 3 sine, cosine, tangent. So when I say in quadrant 2 that sine is positive, also cosecant is positive, right? Just the reciprocal of sine. Same thing with cosine. When cosine is positive, that means so is secant. Example 4, using reference angles to evaluate function. Evaluate the tangent of negative 240 degrees. Let's go through the 3 steps above. 1, find the reference angle theta prime. So we have 0, we have 180, 270, and 90. So negative 240 is beyond 180, and it is 60 degrees beyond 180. This is 60 degrees, and that is my reference angle. So step 1, theta prime equals 60 degrees. Step 2, evaluate the trigonometric ratio function for theta prime. So step 2, I need to find the tangent of 60 degrees. Well, the tangent of 60 degrees is the sine of 60 degrees over the cosine of 60 degrees. The sine of 60 degrees is radical 3 over 2. The cosine of 60 degrees is 1/2. If I wanted to divide those, I could rewrite it as negative 3 over 2 divided by 1/2 is the same as negative 3 over 2 times 2 over 1, which is just square root of 3. Okay, so I've evaluated the tangent of 60. And then number 3, determine the sign of the trigonometric function value from the quadrant in which theta lies. So in quadrant 2, tangent is negative. So we really need to find negative tangent of 60 degrees. And well, we just found the tangent of 60 degrees, so we'll make it negative. And the answer here is negative square root of 3.